Thank you all for joining us today as we're going to talk about the secrets of Neo4j in production. So what we're going to do today is go through a kind of standard tour of how you go from concept of an idea for your application, what you want to do, all the way on to launch, with a special eye towards, what are the right things to do at the right times that are going to make this successful. So of course we're going to go from just the proof of concept stage onto the development stage, and then kind of a critical pre-game planning stage, all of this leading up to the eventual launch of your application. So in the proof of concept stage, we're all familiar with doing this. This is when you have an idea and you want to make sure that the idea is correct. But before you have the idea and you even decide to use Neo4j, first there was a part where you just became aware of Neo4j, and perhaps it's because it seems like these days everyone's talking about graphs. Of course, there's Facebook and Facebook's Open Graph. Google just launched their Knowledge Graph, to make their search a whole lot smarter. Bing, of course, couldn't be left out of the fun, and then so they have their answer to that they're trying to do. And things like the interest graph has been talked about on and off for a few years now. Like, is it better to look at how people are following each other on Twitter or their friends on Facebook? What really matters more? And in all of this, of course, this all centers around just talking about graphs. So at some point, when you're reading all this stuff, probably a name that comes up when looking at graph databases is Neo4j. Neo4j, the world's leading graph database. So, of course, that's why we're here at this webinar today. So, if you've heard about Neo4j, the natural thing to do right after that is to Google Neo4j, or possibly Bing Neo4j, I suppose. Either way, what the search results you come back, of course, you'll quickly find out that there's a neo4j.org, and that's the site around the product itself that is Neo4j. And then you'll probably discover that there's this company called Neotechnology, who's the commercial sponsor of Neo4j. And that Neotechnology has all these great, commercial customers, so that makes you feel a little bit better about Neo4j as a choice, because people are actually using this off in the real world right now. And this product actually is also a project. Originally an open source project out of Sweden. And of course, as an open source project, all the code is available out on GitHub. You can watch the activity as all the developers are, coding out in the open there. And if you'd like to, of course, you can stay on the bleeding edge by staying up to date with all the snapshot releases of Neo4j. And a little bit further, you end up realizing as well that there's meetup groups all around the planet at this point. Which is very exciting. So almost no matter where you are in the world, it's likely that there is already a meetup group of people who are using Neo4j in your community. And if there isn't, of course, you should think about starting one and maybe get in touch with me and be happy to have that set up. And not only are there meetup groups, but there's even a conference that's now being organized in this fall all around graphs. So between Neo4j and the whole graph community and all the excitement that's going on right now, there's obviously a big ecosystem that's going on. So this seems like a good thing to be looking into for your proof of concept. So how do you actually get started if you want to try out Neo4j, though? Well, in that search as well, you probably would have discovered some documentation. There is the lovely Neo4j manual itself, which takes this kind of split approach where half of it is some tutorials, and then the other half is just a very comprehensive reference manual. And in the reference manual, even, it has sections where you can try out snippets of code live within the manual. It's actually interactive. So that's actually a great resource for just getting an idea about what is all this stuff, how does it work. There's even some other books that are coming out now. Manning has a book, Neo4j in Action. There's a Spring Data Neo4j book called Good Relationships that's available. And of course, you can just go ahead and get Neo4j yourself and try it out. You can either just go ahead and download it, and that's available, of course, on all the standard platforms. Or a little bit easier sometimes is just go ahead and try it out on the cloud. We have a Heroku add-on that's available. It's still in public beta, but it's a full Neo4j database that's at your command whenever you'd like to have one. And that's a great way to actually just sort of try out ideas. And in addition to all of that, there's a very active community around this. So we have a Google group where there's a lot of discussion that's going on. I just mentioned the meetups. And of course, we've got an endless number of webinars every month happening all around Neo4j. So there's plenty of sources of information that you can tap into to find out a little bit more about it. So then you step a little bit further, and you hear people mention things like, working with a graph and saving graph data it's all very whiteboard friendly. So to test that idea, you go ahead and go to your whiteboard and you do the classic thing. Graphs, most naturally, I think most intuitively for many people, you start by thinking about graphs as as a social graph, as a social network. I think that's the easiest way for people to start reasoning in graph-like ways. So here I've decided to go and create an incredibly small little social graph. It's just myself, Andreas, and some people that I know. And to make it a graph, of course, I just go ahead and sketch out, all right, there's me, here's the people I know, and some of the people that they know. So great, there's the whiteboard version of that. So ostensibly, I can just take that and put that right into Neo4j in the graph. And if I've downloaded Neo4j, or if I fired it up within even Heroku, Neo4j has this lovely web interface, the web admin that we call it. And in that, you can actually just start using the database directly. You don't have to do any coding. You can just start creating nodes and adding relationships and even visualizing it so that that whiteboard that you just drew, you can quickly reconstruct and have actual data. And now that you have actual data in an actual database, you can even start to write actual database queries. This is a small example of Cypher. Cypher is our declarative query language for traversing a graph and actually answering questions about the data that you have within a graph. Just a little detour about Cypher. You can see that there's 3 clauses here. It's a little bit like SQL that has different clauses, but it takes the idea of pattern matching within a graph. So I just started from my node 0, which I know was me, Andreas, and then I just did a little ASCII art to match from me through some node that I'm not so interested in, and then onto another set of nodes that I'm going to call the friends of a friend. And then I'm just going to return that. So of course, you run that, and we end up finding that, Allison is a friend of a friend. And in this circumstance, she's a friend of a friend that I happen to not yet be friends with. So if I was thinking about trying to do recommendation algorithms, this is the kind of natural way that you end up doing that. You end up finding things that are related that a person perhaps has not yet purchased or has not yet made friends with, and you can extend this actually into just about any domain. But as a proof of concept, this is a great way to just get used to the idea of working with graph data. So you've done that. You've worked with just the graph itself, directly with the data, creating stuff right in the web admin. And now you want to go ahead and start trying to do some coding, perhaps. And there's 2 ways you can approach that. Neo4j is actually embeddable on the JVM. So if you're coding in Java or Scala or even JRuby, you can just fire up Neo4j within your application, and you have a database there on hand, ready to go. Of course, if you take that approach, you can easily deploy to Tomcat or Rails, your choice of sort of container. And this is also very convenient for doing testing. We'll touch back on that a little bit later. And this is actually the approach, embedding Neo4j, that one of our clients, Cisco, has been using this for lots of different projects internally, and they found it incredibly convenient to be able to just have this database on hand right in all of their applications. The alternative, of course, right, I forgot there's a lovely animation that I put in here. Embedding, of course, just means you take Neo4j, you actually put it in the same process as your application itself, so that when users are speaking with your application is actually managing the database directly. The alternative to that is using Neo4j in standalone mode, using it as sort of a normal database server. So when you have it running as a server, there's a REST API that you interact with. And as it's a REST API, of course, you can access that from any language on the planet because everything knows how to speak HTTP, so that's no trouble. And that also gives you a bit more flexibility in different deployment scenarios because you've separated out your application layer from your storage layer at that point. So whether you're creating your own server and deploying it, or you're having it managed in the cloud on Heroku, you can use Neo4j through this REST interface. And this is one of our clients, Migri, which is a professional social network. They actually take this approach. They're using Neo4j in production through the REST API. The way that looks, of course, is that you've got your little application sitting there, and you've got Neo4j running on a separate box, communicating over HTTP, and of course the users are still out on the left there, talking to your application rather than directly to the database. So far, all fairly straightforward. The thing to note, of course, about running an embedded versus server, and because sometimes this can be a little confusing, is that it's exactly the same capabilities you have on hand. Whether it's running as a server and you're accessing it through the REST API, or you have it embedded in your application, Neo4j has the same amount of scalability, the same transactionalities, and the same availability. So it doesn't really matter which of these scenarios you've decided to go down, you still have all the options available to you for scaling out your application. So really, it's worth just thinking about it. It doesn't matter if it's embedded or REST, it's just your users talking to your application and talking to Neo4j. It's a functionally equivalent scenario. So you've decided to either go to REST or perhaps to an embedded, and then you go ahead and do your code spike. And this is the standard thing. You pick your language, you pick a framework to work within, and you hack up some code. And the APIs make sense to you. You're able to actually get something productive done. And you basically end up with a nice little proof of concept that shows that, okay, it looks like Neo4j can store the data that you want to, it can answer the kind of questions you want to have. So it seems like this is probably pretty good. And you're willing to consider that, code spike a success. The question then becomes, all right, there's a nice community. You see that there's a lot of activity around Neo4j. It's already used in production environments around the world. Lots of large customers that are using it. But what do you do next? What's your next step now that you've got the proof of concept? Of course, you talk with your team, you talk with your managers, and you all decide, okay, let's commit to this. Let's start moving towards an actual production application rather than just a code spike. So if you're ready to move to production, this is something that one of our customers, Viadeo, faced. They were in a very tight loop where they had given themselves a very short time frame to look at a proof of concept and then pick something quickly and go right into production. So the first thing they had to decide, though, of course, was which licensing option to go with. They knew that they wanted to have an actual commercial offering. They wanted the commercial licensing to support that. And so they took a look at the options for Neo4j. You can either go with the Community Edition, which of course gives you a full awesome database. If you step up to the Advanced Edition, you then get monitoring. Or Neo4j is also available as an Enterprise Edition. And when you go to the Enterprise, you get high availability, you get 24/7 support, and this is actually the scenario where if you're really thinking in a full production business serious way, that you want to get up to speed quickly, you actually also then can tie in doing some professional training with this. So with Neo4j, we offer like a week-long workshop that really covers the full spectrum that will get your team up to speed quickly with Neo4j. It's obviously, dealing with the graph database is novel for people. So with relational, there's a lot of people who already have that knowledge. You can just start working once you pick a relational database you want to use. Neo4j, there's a lot of new concepts involved, both for the programmers and also for the operational people and also for your DBAs. In this week-long workshop, everybody on your team will get up to speed quickly on how to code for Neo4j, what the operational characteristics are, and how do you query this? How do you actually get data back out of this if you want to run some reports? The way this usually ends up happening, we have a very structured approach where the first few days of a workshop, it is just tutorial-led. It is, we have a set game plan and material for leading through all the material that you need to know. And then it slowly shifts towards focusing a little bit more on being a bit of an interactive lab and almost consulting, where we start focusing on exactly your use case and what you're trying to get done. And like the tail end of the workshops always end up being very customized for every actual customer to get them particularly going as quickly as possible. So you choose Neo4j Enterprise and you decide, all right, let's go on into the development. Now, for development, of course, there's nothing unique about using Neo4j. There's no secrets to be had here. You follow your best practices, whether you want to be test-driven purely, if you want to be more behavior-driven, or if you're domain-driven, you've got your agile practices you want to use. This has nothing to do with Neo4j particularly. You develop the way that you want to develop. But while you're doing your development, what is, of course, critical in almost any discipline is that you do a lot of testing as you're going along. And Neo4j helps out there. It's nice because that embedded mode that you can run in Neo4j, even if you want to deploy ultimately to the server, you can use Neo4j embedded in your unit tests. So if you happen to be on the JVM, that's incredibly convenient. You can just spin up a database when you need to, populate it with some sample data, and just run tests against it. That's fantastic. If you're not on the JVM, you can still use some ant tasks or some rake tasks, depending on your platform of choice. Even just script some stuff up with Bash to sort of do more integration level testing, where you fire up a server, maybe clean it out, and then run your test suite against it. And at this point, of course, you're just using the task for just managing a local server. And it's important, once you start to take that approach, you think about ahead a little bit, where you're going to be in production, what the production environment is going to be like, and it's important to actually, stress the system before the system stresses you, right, once you actually launch. So a key thing here, if you've decided to go with Enterprise, you know that you're going to be headed towards using high availability. So you want to be able to orchestrate clusters. A classic way to do this is to just have, Bash. Bash is always on hand for deploying machines and like very easily reconfiguring things. So that could be one approach for just doing a local cluster that's reconfigured to run. You could have virtual machines that are spun up with something like Vagrant in combination with some chef recipes. That's also very convenient for just doing cluster testing to see how that behaves differently than just using a single server. Or you could even just completely script out an EC2 deployment. This is what Adobe has done. Adobe has been very exhaustive when they were going through their development phase. They were stressing the entire system from end to end, all just with very carefully scripted combinations of Bash and then other stuff as well, so that they could bring up entire EC2 clusters, multiples of clusters, and do the usual thing, of course, is you go ahead and mock some data, you simulate user load, so that the system is going to be as stressed as possible with the actual real-world data, or as close to real-world data as you can simulate. And while that's going on, of course, one of the key exercises to go through is make sure that you're mean to your system. Kick it in the pants over and over again. Tear things down ruthlessly, kill -9 it, do all that kind of stuff, and make sure that it comes back up. Again, the key here is that you want to stress your system before your system stresses you. So as part of that, then, this is really leading into the overall pre-game planning for doing a launch. The key for this is thinking about how does Neo4j itself behave, and then you craft scenarios that actually stress Neo4j and stress your application in coordination with Neo4j to make sure that things make sense. So you can scale Neo4j with just a single server, and your tests should really just start with that to make sure that you can make sense of the data the way that you want to, that everything is just functionally correct, and that the behavior is correct for just your application interacting with a graph. But then you also stress growing the data, seeing what the throughput can be, both between your application and also in reading and writing from Neo4j, so you've got some idea of what you can expect. So the trouble with this about, while a single Neo4j server can handle billions and billions of records, it has some limitations. Performance relies on having things cached in memory, so you're limited to having as much memory as you've got on a single machine. If you want to do backups, you actually have to take the server offline to do the backups, and of course you've got a single point of failure. If you're going into production in many business scenarios, you don't really want to do that. So if you are going into 24/7 production, you really want to think about introducing high availability, HA. So HA, of course, is just master-slave replication. This is the classic scenario where you have multiple machines running, and most likely you've got a load balancer sitting in front of those machines that's directing the traffic. So here I've got this one box that's got a little star on it. So he's currently the master. So in master-slave replication with the Neo4j, you can read and write to any member of the cluster, but there's a little bit of different behavior when you're writing to a slave than to the master. When you're writing to a slave, the slave actually passes that transaction on to the master first. The master commits that, and then the slave commits it. What's nice about that is you get redundancy, but of course it's a little bit slower because you're doing 2 writes to actually get a transaction completed. Or you can direct writes directly to the master, and of course that will be faster, and you then have to rely on the slaves propagating out those changes over time as they are pulling changes from the master. The other aspect about high availability, of course, is that you do that so that you have automatic failover. And any member within the cluster can be elected master. What typically happens on startup is usually the first person who joins the cluster ends up being the master. But if the master goes down, the slaves will recognize that. They'll automatically instigate a new election, and somebody else will become the master. Once the failed master has been restarted, or if the machine was just unplugged, you plug it back in to the network, it can rejoin the cluster, and it'll rejoin, realize that it's no longer the master, and it'll go ahead and just continue to behave as a slave. It's possible, of course, that the timing of this could have ended up causing a branch in the data. There's automatic branch detection, though, and there's automatic resolution for that branch, so you don't have to worry about it. All you have to worry about is just starting that server back up again. It'll rejoin, and then everything will continue. The other thing that's nice about high availability is because you're running in this clustered environment that's just using a network protocol for keeping the servers in sync, you can actually run backups that run live. So the backups just really join the cluster, and they pull the latest updates, and the backup that it creates is actually a full directly usable Neo4j database. So what's nice about that is you basically have a hot backup at that point. So when you need to restore the cluster, all you end up doing is you shut it down, you distribute the backup to, in fact, you only have to distribute it to one of them and clear out the databases from the other. And then when you start the cluster up, that'll get propagated out to everybody in the cluster, and then everything is back up and running again. So high availability, just those basic functions of having the master-slave replication and having the live backup like that, is a critical part of having disaster preparedness. Like I said earlier about stressing your system first, you have to assume that things are just going to go wrong. Hard drives are going to fail, power is going to go out, things happen in a live environment. And that's, of course, the trick with having even a single host cluster. You could run just a single host and consider that to be a cluster if you wanted to, if you're running that in HA mode, so that you could at least then get a live backup of that single machine. It's not an ideal scenario, but if you're constrained on the hardware resources that you have on hand, this is at least better than just having no backups at all or having to power down to get a backup. So this scenario, at least, is kind of the minimum for actually being in a live scenario where you can have as immediate as possible recovery from any problems. A little bit better, of course, is having actual high availability that I just described, the master-slave replication. So that's when you have, assumedly, just a single data center, and you have multiple machines within that data center, all of whom are participating in the cluster. And this is for getting the redundancy and also for getting higher availability for just reads. So that if one of these machines goes down, of course, the rest of the cluster continues to operate without it. And everything's completely happy. So the other way that you can go, we're just kind of elaborating all the different options now that you have the ability to have a cluster, is to actually have a physically separate location for one cluster member or maybe a few cluster members, and you call this your disaster recovery data center. And you don't generally direct any of your public traffic over to it. You're purely using this other center so that you've got a backup that if the entire data center goes down, if it gets hit by a tornado or just has a power outage because somebody dug into a line, you can then actually fail over to a physically separate location altogether and continue to run. When you're running with a disaster recovery data center, you want at least one cluster member over there. It's just operating as any other cluster member, but typically you just have it set as just a read-only mode, so all it's doing is keeping up to date with all the latest changes. And when an actual disaster happens, and the entire cluster gets set to fire and goes down, you have some choices. You can either try to restore and quickly restart that cluster, or if you wanted to, you could actually redirect public traffic, depending on how your network is set up. You can just redirect traffic to the disaster recovery and just use the backups that's over there to restore the system, so to really minimize the downtime of your application. So elaborating a little bit more beyond that, of course, is having multiple full data centers, where you have, again, distributed physical data centers, but more importantly, you typically have these data centers optimized for network availability. Typically, that also means that they're geographically distributed. You might have an East Coast and a West Coast, maybe something in the Midwest, like in Chicago, where you've got a data center so that you know where most of your users are. You try to get the data as close to them as possible. Now, when you're running in this mode, when you've got multiple data centers running, you might want to consider that each of these is basically just a different zone, and you might designate one of the zones that has the lowest overall latency as being the only place where writes will happen. Because you have to remember that writes are typically slower than any kind of reads, so you want to minimize that for everybody because all writes will always happen through a single master that has all the locks. So you pick your lowest latency zone and then set that as the master, and then run everybody else as just read-only so they're polling. Now, of course, you can take that to an extreme as well, and not only be geographically spread across the nation, and this is what Adobe has actually done. You can have continental data centers. You could have a data center in North America, you could have a data center in Europe, you can have a data center in Asia, and still just treat that as one giant logical cluster. The latencies involved here, of course, become really horrific. I mean, just round-trip ping times from Asia to Europe can at times take up to 20 seconds, which is not really ideal, but it's manageable. And Neo4j is actually set up so that it can handle this all just fine. Adobe's running this live now as part of their Creative Cloud. So this is kind of the ultimate in both redundancy and availability across the world. At this point, you're assuming each data center also has its own local disaster recovery and backups so that it can catch up and be available as much as possible. But this is the complete, the Cadillac of having everything you could possibly want for deployment. So that's really it. I just noticed that Jeff said his servers burned down just like that. It happens, doesn't it? It's frightening. So the thing about the secrets of Neo4j in production is that there are really no secrets. The secret is that you do what you would normally do for a good, responsible business application, where you prove the concept, you make sure that Neo4j is going to actually answer the questions that you want to ask, develop your application as you normally would, and it's step 3 here, really, that's the most critical one, that you prepare for the worst. You assume that things are going to go wrong. You have backups. You've got a cluster that can handle any kind of problems. You've got recovery systems, and you stress it. You try to actually make it fail before you actually take step 4 here. And step 4 is what all this is, of course, leading towards. You've done all of your homework. You've done lots of testing throughout the system, and then you're finally ready to just go ahead and launch.